This is the first problem. You may pause this video and read the question properly. We draw the figure like this. Here we see that a person throwing the stone goes up and way down to touch water under the bridge. We write the three equations of motion. We should realize that time is the only scalar quantity. Final and initial velocity are vector. Acceleration is a vector, and the height the displacement is also a vector. This is one-dimension problem, and by vector means we will consider up as positive and down to be negative. Initial velocity is positive 4 meters per second. It is upwards, so positive. And time is 4 seconds. Acceleration in always down, so negative 10 meter per second square. The ask is the height, d. Now, here is the question for you. Among the list of equations, which equation of motion works best? The answer is, it is the second equation of motion. So we apply the second equation. With little bit of algebra, we find d equals negative 64 meters. The negative value just means that it goes further down below the person by 64 meters, which is the height. This is the answer. Now, for the next question. This problem can be solved by dividing the velocity into vertical and horizontal components. You may know that the upward vertical velocity slows down because gravitational acceleration acts vertically downward. At the top, which is point B, the vertical velocity becomes 0. The horizontal velocity always remains the same. At point A, point B, and point C, it is constant because there is no horizontal acceleration. The horizontal velocity is 20 times cos 60, and cos 60 is half. Therefore, the horizontal velocity is 10 meters per second. The vertical velocity is 0. Hence, the velocity is same as horizontal velocity. Hence, the velocity is 10, and the answer is D. For the third problem, it is straightforward procedure. Differentiate position with respect to time to get velocity. Then substitute time tt equals 0 to get initial velocity. We get the initial velocity as gamma. Differentiate again to get acceleration. Now substitute time t equals 0 to get the initial acceleration. We get the initial acceleration to be 2 times beta. The question asks to find the ratio of initial velocity and initial acceleration, and it is gamma to 2 times beta. The answer is D. Now for the next question, this problem is about a body falling, and the equation is given by dv by dt equal to 4 minus 2 times v. To solve this, we know at terminal velocity, the velocity is constant, or the acceleration is 0. Acceleration is dv by dt, which is given. Hence, we have this relation to be 0. And we solve the algebra and get terminal velocity equals 2 meters per second. There are two choices for terminal velocity equals 2 meters per second. The initial velocity is not given. The question is a bit fuzzy. We can only assume that initial velocity is 0 as it is falling freely, which means the initial acceleration is 4. So answer is A. Let us go to the next question. To solve this problem, we consider firstly this figure where the buses are only approaching Scooty. In the next page, we will consider the buses going away from Scooty. The velocity of Scooty is 60 meters per second. Let us assume the bus velocity is v. Then the relative velocity of bus with respect to Scooty is v plus 60. If the gap between buses are L, then the time taken for approaching bus is L, divided by v plus 60, which is also 10 minutes according to question. Since we have considered unit of time in hour, we divide the 10 minutes by 60 and convert into hour. This is the first equation. We do the same analysis for the buses going away from Scooty. Let us do on the next page. In this next page, we have the equation we previously derived. We show you the new figure 2 with buses moving away from Scooty. Now we consider where buses that are moving away from Scooty. The relative velocity of the bus with respect to Scooty is v minus 60. The time taken between the buses that are moving away is L divided by v minus 60, and according to question it is 30 minutes. We consider the unit of time in hour, so 30 divided by 60. We have two equations. We solve for v. We do a bit of algebra and get velocity equals 120 kilometers per hour. This matches with the answer B, so do not need proceed to find the time period t for the bus to pass by relative to stationary observer. As a teacher, I will calculate the time period. We take any one equation to calculate L. We substitute v and get L as 30 kilometers. The time period between the buses is L divided by v, which comes out to be 15 minutes. We have come to end of this video. If you like our teaching, please like and subscribe to see more such video. Thank you.